section of notes, and we're going to talk about the combined gas law. So the combined gas law is a single expression that combines three different scientists' laws: Boyle's law, Charles' law, and Gay-Lussac's laws. This gas law describes the relationship between temperature, pressure, and the volume of a gas, and we've seen that in the PhET simulation over and over again. It allows you to do calculations where only the amount of gas is constant. So again, the number of particles is always the same in this instance. The only thing that's changing is pressure, temperature, and the volume. These guys must have been BFFs. Their ideas are so connected to each other, we can actually combine all three of them right into one combined gas law. We've looked at the PhET simulation. If you'd like to click on this link or go to this link yourself to explore gas properties, feel free to do so. Now, the combined gas law is P1 times V1 divided by T1, and I'll explain what those mean, equals P2 V2 over T2. So this is basically the pressure, volume, and temperature at the start, that's the 1, will equal the pressure, volume, and temperature at the end. Helpful hint? You're going to be able to get the law you need by covering the variable that's not mentioned in the problem. Use your reference table to find the combined gas law. So, copy that down for your notes. P1 V1 divided by T1 equals P2 V2 divided by T2. For example, if there's no mention of temperature in a problem, you can cover the T up and you're left with the relationship between pressure and volume, which is known as Boyle's law. You can cover that right up, put your thumb right over it, and you've got Boyle's law, and those are the factors you're going to need. If there's no mention of pressure in a problem, cover the P up, and you're left with the relationship between temperature and volume, which is also known as Charles' law. There you have Charles' law. If there's no mention of volume in a problem, cover up the V, and you're left with the relationship between temperature and pressure, which is Gay-Lussac's law. You can see that this combined gas law is very handy. All we're looking for is what is missing in the problem, or if all three things are available, you're going to be entering all three values. Here's an example. A gas occupies 3.78 liters at 529 millimeters of mercury, or torr, and it's at 17.2 degrees Celsius. At what pressure would the volume of gas be? 4.54 liters if the temperature is increased to 34.8 Celsius. Now, this seems like a lot of numbers, but if we just put the different variables where they belong, this becomes a very easy question to solve. We need to know P1, V1, T1, P2, V2, and T2. So the first pressure is 529 millimeters of mercury. The volume is 3.78 liters. Our temperature we have to convert into Kelvin. So we're going to add 273 degrees to our degrees Celsius, and we'll get 298.2 degrees Kelvin. We have to solve for our temperature. That's our question mark. We have 4.54 liters, and our volume is, that's all kind of out of order, isn't it? Our pressure we're solving for, and we have a volume of 4.54 liters, and our temperature is 34.8 Celsius. We add 273 to that, so our final temperature will be 307.8 Kelvin. All right, so there's our formula. P1 over P1 times V1 over T1 is equal to P2 V2 over T2. All right, so let's put this right, substitute the values in. Here's our first pressure, P1. Here's our volume, V1. We're going to put that over our Kelvin temperature at the start. That will be equal to, we have to solve for P2. We're looking for what is the pressure. Substitute in the volume at the end of our experiment. put that over the temperature at the end of the experiment. Now all we're doing is we're going to go ahead and we're going to solve for the pressure. So this just becomes an algebraic equation. You solve, and the answer is 467 millimeters of mercury. Again, you weren't asked to change from millimeters to mercury to a different pressure, so we can leave it right there. So now we're going to give you time to go ahead and practice gas laws, and we'll walk you through how to do some of these.